So this is the video to help you do the first lesson in chapter 2. I'm calling it lesson 2.1a, and you should be doing this after the test on Monday, the 14th. I think it's 14th. Okay, so the purpose of this lesson is all about percentiles, which you may or may not have heard of, as well as, as well as we're building up to being able to do a cumulative relative frequency graph. So that's our goal, cumulative relative frequency graph, which is made up of percentiles. Okay, so first we need to talk about percentile a little bit. And I want you to treat this just like you would do in class, where it's like you're going off to a breakout group and working on stuff, and then we come back and talk about it. You don't have a breakout group because it's just you, but I'm going to tell you what to do. Then you pause the video, go do it in your little breakout group of 1. And then when you're ready, come back, unpause the video, and we go over it. So it should feel the same as in class. So I want you to read through the beginning, and I want you to do numbers 1 and 2. Do it on your own. Pause the video. And then unpause it when you put your full effort into 1 and 2. All right, pause. Okay, so you hopefully were able to do 1 and 2. So let me show what I have. Okay, and describe the distribution. Just a reminder that you need to do SOC V plus context. There was no comparison here because there's only one distribution. I was able to pretty much state everything, although the outliers I had to do some math. So I actually found the IQR, and I found 1.5 times IQR. And then I went that distance away from the quartiles and then looked to see if there were any dots outside of that, and there were. There were, in fact, 2 outliers. Okay, so in my description, I made sure to talk about shape. I said fairly symmetrical. Notice I used an ly word to soften it because it's not perfectly symmetrical. I mentioned the outliers. The center, I talked about the mean and the standard deviation for the variability. You could have also used median and IQR. That would be totally fine. And then context was involved. Use another color. So context, I talked about the distribution of heights. So the context was established there. Oh, and also there's inches. That's specific context, that kind of thing. Okay, great. So then we got into starting to get into percentiles and what a percentile is. So Ariana was 65 inches tall. What percent of heights are less than or equal to 65? And this is a good point to point out. If you did the review assignment for chapter 1, there was a percentile question that accidentally made it on that review packet, and I accidentally told you something wrong. In my head, it was everything below that point, but it's everything below or equal to that point. So, sorry, it includes that point. Okay, so for 65 inches tall, here she is. So there are 1, 2, 3, 4, 5 points at her spot and below. So 5 out of the total of 20 is 0.25 or 25%. So this, you would say she is at the 25th percentile. She is at the 25th percentile. Okay, so percentile is the percent of the data that is below you or equal to you, at you or below. Okay, and then the next one I did for my own personal height. I'm 70 inches tall, so for me that puts me at the 80th percentile. Your number likely looks different unless you happen to be my height. All right, so now I'm going to help you start this table, and then I'm going to let you finish it, and then we'll do the graph down below together. Okay, so complete the table. Frequency, okay, let's back up a little bit. We are building up to cumulative relative frequency. We're building up to that. So let's think about what each of those words mean. First of all, frequency is just a count. It's how often something shows up. Relative frequency turns it into a percent of the whole. And then cumulative means adding it all up. So all these relative frequencies added up. Okay, so we're going to build this up. So for a height of 56 to 60, let's go look up above. Maybe I'll change colors again. For a 56 to 60, I see 1, because here's 60, right? So that means there was a frequency of 1 there. 61 to 65, I see 1, 2, 3, 4. So there's 4 in that group. So you kind of get that idea. Now let's talk about relative frequency. So if frequency on the first row was 1, the relative frequency is the percent of the whole. So that's 1 divided by 20. And if you do that as a decimal, 1 divided by 20 is 0.05 or 5%. In fact, it might just be easier if we just call it a percent. So 5%. 4 in 61 to 65, let's turn that into a relative frequency. 4 out of 20 is 20%. Okay, now cumulative. We're basically just going to add these up. We have our relative frequencies there. We're going to now make it cumulative. We're going to add them up. So this is 5%. But now cumulative, we're going to add them up as we go. 5 plus 20 is 25%. And whatever that third percentage is that you're going to get, you would add that now to 25% to get in the next row. Okay, so I'm going to pause here. Try to figure out how to do the table. Finish the table if you can. If you're totally stuck, unpause and I'll go over it. But pause here, try to finish the table on your own. Okay, so here's the rest of the table. Again, the 1, 4, 11, 3, 1. I just pulled off of the dot plot up above and just counted how many landed in that category. Relative frequency is I took that number in the frequency and divided it by 20 to get a percent of the whole. And then cumulative relative frequency was just adding up those percents as we go. So 5 plus 25 plus the new 50. So let me change colors. So 5, nope. I take that back. 25 plus 55 gave me 80%. 80 plus 15% gave me 95%. So I'm just adding up those percents as I go. So really what all this is giving me in the end are percentiles. This last column is just percentiles. It is saying if you are at that spot, I don't know, 70 inches or whatever, 80% of the data is at your spot or below. It's this last column is just percentiles. Fancy way to say it is cumulative relative frequency. It's just a percentile. Okay, so now we're going to graph this data we got in the table. We're going to graph our x-axis is the heights, and our y-axis is the cumulative frequencies. So this is our x's, this is our y's. Okay, so we have our numbers on there. We have these percents. And by the way, on the y-axis, it could not be 100. It could be 1.0. You will see it both ways. Sometimes it's as a percent, and sometimes it's as a proportion, as they call it. So it could be either one. Just FYI. Okay, so let's do, what did I do? Green. Let's stick with green. So let's fill in our table. Maybe I'll do this so we can see it all both at the same time. So 56 to 60. Okay, so 56 to 60, that's our first bar. By the time we get to 60, we've reached 5%. This graph will always start at 0, by the way. Cumulative relative frequency graphs always start at 0 because at the very beginning, you don't have any of your data yet. You have 0% of your data. And it will always build up to 100 by the end. Okay, so that 60 is 5%. If we're 61 to 65, so by the end of that bar, by the end of 61 to 65 is 25%. So that's about right here. 66 to 70, by the end of the 66 to 70 bar, we're at 80%. So by the time you get to 70, you're all the way up here at 80%. And then what, 71 to 75, by the time you get to 75, you've added up to 95% of your data. And by the time you get all the way to 80 at the end, you've got 100% of your data. So this is a typical cumulative relative frequency plot. Let's see, sometimes it's connected, a lot of times it is, just to help your eyes see what goes where. It's kind of like a bar graph. If you were to create, well, a histogram of this and connect the top of the bars, you would make this. Okay, let's add a few formalizing details. So this always goes up to 100% or 1.0. These graphs always start at 0 because you start with none of your data and you slowly build up to all of your data. Remember that this is just a percentile. And then something to keep in mind, something like right here, this has a really steep slope, right? It goes up really fast in the same interval as all the other ones. So that means it's building up a lot of data all in that one spot. So that means you have many values in that particular bar, which we do from 65 to 70. If we go back and look at our bar graph, 65 to 70 was a huge chunk of data. So all within that one interval, we added a whole bunch of data. A high percentage of our data landed there. And we can tell that because it has a steep slope. Okay, great. So now we are going to do the big ideas, important ideas. The first learning target was around percentiles and what that is. Percentile, let me make that singular. A percentile is the percent of values that are less than or equal to a given value. And we talk about being at a percentile. Your SAT score was at the 85th percentile. So that means 85% of the people who took the SAT that year did as good as you or worse. Okay, and then learning target number 2 was about a cumulative relative frequency graph. So cumulative relative frequency graph. And I wish they called these percentile graphs because that's all it is. Just a percentile graph, and that would be much easier to say. Okay, they always start at 0 and they always end at 100 or 1.0. So they start at 0 and at 100. So they always start in the lower left-hand corner and end in the upper right-hand corner. You have your data values down here. And then it looks, like it starts at 0, and I'm just going to make up another one. It looks something like this, where, it like starts lower left hand, ends up in the upper right hand. And what you're building up are percentiles. Okay, the last thing that's going to show up that will be helpful to know, remember that quartile 1 is always at the 25th percentile. It is 25% of the way into the data. It's a quarter of the way into the list of numbers. So quartile 1 is always at the 25th percentile. That's a shorthand way to say percentile. The median is at the 50th percentile. Oh, okay. Hang on. I should be putting little THs in here. 50th percentile. And quartile 3 is at the 70th percentile. Because that's always, 50% of the way into the list or 75% of the way into the list. Okay, so those are your big ideas. So at this point, I want you to do the check your understanding. There are 2 problems. So you're going to pause the video. You're going to go do the check your understanding as best as you can. And then you'll restart the video. And at that point, I will be going over it. And then that will be the lesson for today. All right, pause the video and do the check your understanding. Okay, so looking at number 1, this is an interpretation question, and they have questions like this on the AP test, and it's easy when you're doing your homework to just skip them because you're like, I don't want to explain what that means, but you really do have to practice the wording and getting the wording correct. I'm telling you, it will haunt you if you skip these. Okay, so basically we're learning that 87% of girls the same age as Ms. Monson's daughter have a weight that's less than or equal to her daughter's weight. And 67% of the girls of the same age have a height that is less than or equal to her daughter's height. My own kids, I'll just tell you, as a parent of young children, we go to the pediatrician once a year, more often when they're babies. And the first thing they do is tell you the percentiles of your kids. They tell the height and weight, and when they're a baby, their head size percentile. And my oldest, Blake, has always been like 97th, 98th percentile in both height and weight because he is a huge little bugger. He always looks about a year or 2 older than he really is. And he's just, both me and my husband come from big families, and he's just a big little dude. My other son, Carter, he'll typically have like a percentile around 80% for height, but 40% for weight. So think about, what does Carter look like? 80% for height, 40% for weight. So he is a little taller for his age than an average boy his age, but he's a little skinny mini because he's our child that won't eat. So he's a little bit tall and pretty skinny. And Blake is just big in general. He's not fat. He's just tall. And because of that, he's heavy. He's proportional for his height. Okay. So what percent of calls lasted less than or equal to 30 minutes? So this takes really some tracing on the graph, and you really are estimating. They said about what percent. So that's a hint. We're looking for estimations here. Okay, so 30 minutes, I just had to trace that little guy up and then over to match up 30 minutes with a percentile. And I guesstimated around 70%. You might have gotten something a little bit different. That's fine. It's an estimate. So 70% are less than or equal to 30. Not 35, because apparently your math teacher can't do math. That would make about 30% that are more than 30 minutes. Okay, so then estimate quartiles and IQR. Remember that quartile 1 is at the 25th percentile. It's 25% of the way into your list of data. So I go look for the 25th percentile right here, and I trace the other way. And I guesstimated 13 for a call length. And 75th percentile, again, trace on over. And I guesstimated, what did I guesstimate? 32. So I have little approximation signs to show that it's just an estimate. And so I got 13 and 32. And then if you subtract those, you get about 19 minutes. So your answers might be off a little bit from mine. Totally fine. It's just an estimate. Okay, so that is the lesson for today. We will start off next class talking about percentiles a little bit, but I'm going to assume at this point that you understand what they are. And percentiles are going to play a big part in what we're doing in Chapter 2. Okay, that's it. Take what you've done, what you've written down, and turn it in for the classwork for today.